is horrible.
Yeah.
Python and Perl, I think, are one of the fastest.
Yeah, they're very, very
interpreters.
efficient output templates.
Half our stuff,
It's amazing how fast they can be, and they're still interpreted language.
It's funny how runtimes vary so much from program to program. Thank you, ma'am. Have a lovely day.
Thank you, you too.
We'll try. Got it. I'll stay with you. Thanks, Hank.
What are your thoughts on national robotic programming language? What would you use? I keep hearing MATLAB, so people think they use C++.
Robot C.
Not C++.
You didn't do the last problem.
Which one?
Yeah, you didn't, you said you were gonna put the solution
Oh, I
in the
did,
last
you're
one.
right. I'm sorry about that.
Yeah, I know we're right, because I looked this one.
Yeah, I know. Sorry about that, guys. Anyway, I'll make sure I put it up before the end. Sorry about that. I literally just had, for the Honor Society, we had our induction ceremony on Friday. And like, entire Thursday and Friday was just doing that stuff.
Because I looked at that thing and I was like, you know how to do this,
Yeah.
but.
Because I think I'm in it, but I never went to a ceremony.
Oh yeah, it's optional. I mean, you can.
Okay.
Anyway,
I still need to sign up for that thing.
yeah. You asked me, quite honestly, like with robotics, you probably want to use something that's a little bit more conducive to, thanks, Angel. You probably want to use something that's a little bit more conducive to Boolean, because quite honestly,
Like lab use.
yeah, something like that, or, something that's. Did you want something?
No, what is it out there?
Oh, this was the actual assignment itself. Is that okay? Okay. Because I figured that way when you look back at it. Yeah, it's not like I just stapled nothing to it. But, I'm trying to think, like, logo is probably good, but nobody uses it. Like, it's an elementary sort of
Unless you're gonna
language.
make its own operating system.
Yeah, well, quite honestly, like,
That would be the best.
that's the way to go, make your own OS. Of course, by the time you're done doing that, then the robotics thing itself seems pretty trivial. So, thank you.
But no, where I work, the little robots and satellites and stuff they make was until very recently, was always its own operating system.
Really, yeah, a lot of companies do that, so that way people can't steal things. I mean, it just makes it easy, confidentiality.
Yeah. But now they're starting to use, still proprietary, but off the shelf software.
Yeah, you're welcome. John, can you pass this one? No question. You have a longer day, sir. I'm not even gonna get you. And what? Just put your name on the paper. There you go. You're welcome. You're welcome.
Thank you.
See, I like the idea that nobody rational wants to work with that stuff.
Or we got factorial in that.
Thank you, sir. Appreciate it.
That's like the part, that's like when you got it, and so you could write, it's just like,
Fun is.
Integral for my favorite.
Everything else is not.
well, it's kind of, the entire thing is in it.
Yeah.
Factorial, okay, you know what it is.
I think it's just because the answers were so clean. You got such clean answers. I don't know, I liked having clean.
Oh, our statement. Thank you.
Partial fractions, like this one. That was easier than.
Yeah, I love in there. That was a pretty fun job.
Took me like, I think it's 2 lines until I could see the factorial. It's just that. But it wasn't as good as the original. I'm ready to run this. It's fine.
But now I don't want to do programming. I want to do video game writing.
Thanks.
Yeah.
That's a hard industry to listen to, hard to.
Yeah.
It's just a video game writing. That's hard because they're like, okay, we're gonna make the game first, right? Well, in American stuff like that. They're gonna make the whole thing first. And then they're gonna say, okay, now make a story based off of what you did. It's not write a story and then we'll make it based off of your super creative story. It's the other way around. So you have like these little tiny boxes. In Asia, it's the other way around. You write the story and then the game evolves into the story. That's why like Japanese games have like second stories, Final Fantasy, and stuff like that.
I thought that's
What's that?
24th, right? It's on 24th?
19.
On the syllabus it says 24th.
I know. There's the statement at the bottom that says, I reserve the right to change with reasonable notification to the student. 2 weeks is reasonable.
Oh,
Yeah, check that out. You always read the fine print.
okay. So it was 24th. We have some day. We can practice during the weekend.
Okay. Then practice this weekend. You'll be okay. Trust me.
You changed the exam date, is that what it's?
Yes,
You moved it up in class, didn't
I
you?
did.
Is that because we're just that good, or because you're just, don't wanna fall behind?
Neither. It's just, generally what I found out is that if I wait too long after I've instructed material, people seem to do worse on it. So, and we're at a good pace to where we're not losing time and I'm not rushing through anything, so.
That's how it goes with anything, if you don't use it, you lose it.
That's true.
This is just the same thing that's on Blackboard, right?
Yep. Yeah, because not everybody uses Blackboard. Yeah, all this is already on Blackboard, so you don't have to write it down if you don't want to, but like I said, for those of you that refuse to look at the announcements in Blackboard, at least I can say, well, it was on Blackboard and I put it on the board in class. So, what's that, whiteboard, yeah. Yep. All lives matter.
There's a couple more colors.
There's not a chalkboard in here, so green lives matter. Whatever. Okay, so obviously, this is what's going on. So I think we have to do 2 more indirect proofs, and then we'll be done with indirect proof. And then we're going to take a look at sequences and series, and we should finish up all that stuff today. So then on Wednesday and Monday, we're going to look at something called mathematical induction, which is our last type of proof that we need to go through. And then that should take us about a class and a half, and then for the other half of class next Monday, we'll review for the examination. Okay? And then probably what I'll do is I'll probably just post like a list of how the exam's going to go. But basically it's going to be like 10 2-point short answer questions, and then I'm going to have 6 proofs. So that's how the test is going to go. So I'll post it on Blackboard as it gets a little bit closer for you guys. Okay? And then for the assignments, next Monday assignment 6 will be due, and then the following Monday assignment 7. Okay, so we're getting there. So any questions, guys, as to what's going on before we get started? Okay, pretty straightforward. Okay. So one of the sneakiest and classical types of proofs that always occur in mathematics, and I think for those of you guys, if you're a pure math major, if anybody's actually doing that, this is something you guys might see in an abstract algebra or abstract math class. So it's a little bit sneakier proof, but I just want to prove that root 2 is irrational. And just because it's one of the most complex proofs, and if anybody ever looks in the book, you might have seen this, and it's a fairly intimidating proof. So I want to make sure that if I was to ask you guys to prove something like the square root of 3 is irrational, you guys can do that sort of thing. All right. Just like we did on Wednesday last week, anytime you have anything with an irrational number, use contradiction. It's the easiest way to go. Okay. So let's suppose not. So here's our proof. We always start our proofs that are by contradiction by suppose not. And hopefully this is really easy. Guys, what's the negation of root 2 is irrational?
It's rational.
It is rational, right guys? So let's say suppose not. Suppose root 2 is rational. And again, guys, the reason we utilize contradiction is because, especially for irrationals, is because we don't have a definition for irrational, right? But we do have a definition for rational. So what can we say about root 2 because it's rational, guys?
You can write it by A over B.
Sure. So by definition of rational, okay, so by the very definition of rational, we can say that the square root of 2 is equal to A divided by B. Okay. What else do we have to say
A,
with
B are
definition?
integers,
Okay, A and B are certainly integers.
and B
So A
cannot
and
be.
B are integers. We should certainly say that B is non-zero. And there's one other thing that we said about rational numbers that I said you'll never need to use it except for maybe 1 or 2 proofs. This is 1 or 2 proofs. So what's the only other condition for rationality? Anybody remember? They don't share something. It's okay. They don't share common factors. Okay? So, and that's going to be the contradiction that we're eventually going to run into in this proof. Now, every other proof, that's good, Eric. So, thanks, Dan. Oh yeah, that would be helpful too, wouldn't it? So, thanks, Dan. So, we're going to say that A and B share no common factors. All right. So now that we have this, okay,
One thing, A, B share no common factor, is that for rational numbers or?
correct, for rational
Okay.
numbers. Definition of rational means it has to be in lowest terms.
Terms, okay.
Okay, so that's what A has no common factors. And again, that's going to be essential to this proof. Okay, so now that we know that they don't share any common factors, we could say that the square root of 2 squared is equal to the square root of A over B squared. Okay, that's true, right, guys? Okay, nobody doubts that. And the only reason I'm doing this is just because I don't have anything else to work with at this point. And I'll fill in the steps as we go along with this. Okay? This is the same as saying that 2 is equal to A squared over B squared. Right, guys? That's just by multiplication. Okay, that doesn't hurt anybody's feelings, hopefully. And then I guess what I could also do algebraically is I could multiply both sides by b squared. So I could say 2b squared is equal to a squared. Okay, so let me let you guys copy that down. We can just fill in the steps as well. We might as well go ahead and do that. So this is just by exponent rules, exponent rules. So, okay, so this is by multiplication, and this is by multiplication as well. All right. So, what can we say about a squared? Anything?
A square is equal to square root of 2b, square root of
Yeah,
b?
we could say that. Okay, I mean, you're right. It doesn't help us, but you're right.
Oh, a square, so a times.
So what can we say about a squared? It could equal n. Well, what does it have a factor of?
2.
Which
Oh,
means it's, if something has a factor of 2, what does that mean?
then it's not a
Then
rational.
it's even, right?
Even, yeah.
Okay, so what we're going to do is we're going to say thus a square is equal to 2b squared, which means it's even by definition of even. Okay, so this is a really sneaky proof, by the way. Okay, so I'm just making sure, like as we're going through this, at the end of it, you'll see why we have to use this definition. Okay, so we're going to say thus a square contains a factor of 2 and is even by definition of even. All right. Now, since a square is even, can we say anything about A? A must be even as well. Okay, how do we know that?
That's the rule of what's it, even numbers, right?
We actually proved it, okay? Didn't we in class by contraposition or maybe we did the odd one, I can't remember what we proved in class, but I think we proved either last class or for homework, I asked you guys to prove that if a squared was odd, then a must be odd as well for all integers, or for a squared even. I think I might have asked you guys to do that for homework. So this was proved previously, okay? If I give you guys this proof on a homework, I'll give you that hint that you don't have to prove that again, okay? So since a squared is even, a must also be even. Okay? We'll just say proved previously.
Do we have to say proof previously?
You could just say either that or by a hint if I give you a hint, okay? But you have to just make sure, like, you know, I mean, something like that, this would be its own proof. We would have to prove that by contraposition if I never gave you like a hint or anything like that. Okay. So, everyone good so far, guys? Any questions at this point? A little bit sneaky, okay? What does that mean about A then? Okay, so A would be equal to 2K, right? Because A is even, okay? So by definition of even, A is equal to 2K, where K is an integer. Okay, I like that. All right. So now that we know that A is equal to 2K, couldn't we substitute 2K back in right here for A squared? Okay, I mean, that's basic substitution. So we go right here, back substitute. Okay, so by substitution, we can say that 2b squared equals A squared is going to become 2b squared equals quantity 2k squared.